Welcome back. We are discussing the lesson carbon compounds, wherein in the previous session we have discussed about the hydrocarbons and the type of hydrocarbons. There are of three types: alkanes, alkenes and alkynes. Alkanes contain single bonds only, whereas alkenes contain double bond and alkynes contain triple bond. We also saw how to write the structural formula for hydrocarbons stepwise. We know that carbon is a very friendly element due to its property of tetravalency. It can form covalent bonds with 4 more elements. In the previous class we have discussed only about hydrocarbons, that is, carbon is forming covalent bond only with hydrogen atoms. In today's class, we will be discussing about the covalent bond carbon forms with atoms other than hydrogen. Let us get started. How does carbon form bonds with other atoms? Let us say the simplest alkane we have, that is methane. So when we say methane, meth means one carbon, so we have one carbon and it is an alkane. Alkane formula is CnH2n plus 2. If n is equals to 1, then the formula will be CH4. So this is the structure of methane. Now, in order for carbon to form a bond with another atom, it has to displace one of the hydrogens. A hydrogen atom should be removed, only then another atom can take its position. So, such atoms are called as heteroatoms. So, these are elements other than hydrogen which can bond with carbon, forming carbon chains. So these atoms could be oxygen, nitrogen, sulfur or any other halogens, for example fluorine, chlorine, bromine, etc. So when these elements are present in a carbon chain along with hydrogen or other than hydrogen, these are called as heteroatoms. Hetero means different. So these are different than hydrogen. Sometimes these atoms may not be present singularly. For example, let us say in the place of hydrogen, hydrogen is removed and in its place, let us say, one of the halogen is present. So this is a singular atom. There could be groups of atoms attached to the carbon chain. Such groups are called as functional groups, about which we will be discussing in detail. So rather than being present as a single individual element attached to the carbon chain, these heteroatoms can form functional groups. They are called functional groups because they decide the functional or chemical properties of the carbon compound. So functional, the function of the carbon compound is decided by these groups. Therefore, they are called as functional groups of the carbon compound. So, today we are going to discuss carbon compounds containing atoms other than hydrogen. It could be halogens or it could be functional groups. In general, we have to learn about four important functional groups which gets attached to the carbon chain. So firstly we have halogens. Functional group is called as halogens. So these are nothing but fluorine, chlorine, bromine, etc. The halogens. So this line here suggests that there is one valency free, and using this one valency it can attach itself to the carbon chain. So as you can see clearly in this case, it will displace the hydrogen and one valency is freed up. So it will use the single valency to join the carbon chain. And what would be the name of the compound in the case where halogens attach to the chain? So the name would be added as a prefix. So we saw that in alkane, alkene and alkyne the name will end with the ene or ine, whereas if halogens are attached to the carbon chain, their name will come in the beginning of the name. So it's a prefix. So for example, fluoro, bromo or chloro. So let us now write the name of this particular compound that we have got. So as you can see here, the group, functional group which is attached is the halogen group. How to write the chemical name of such compounds? It is exactly same as we did in the previous class. Number one, count the number of carbon. How many carbon atoms are present? In this particular carbon compound, there is only one carbon atom present. Carbon compound containing one carbon, it begins with the name meth. So then check the bonds. What kind of bonds does it have? Is it single bond? Does it have double bond or triple bond? In this case, all the bonds are single bonds. Therefore, it is an alkane. So the name will end with the ane. Methane. Also, here in this case, there is our functional group present halogen, and as you know, when halogens are present, their name gets added as a prefix. It comes at the beginning of the name. So how? Here it is chlorine, so it is added as chloro. Therefore, the name of the compound is chloromethane. So simple. If let us say instead of chlorine, bromine is attached. So in that case, the name of the compound will be bromo. So bromomethane. That's it. So it is an alkane, or we can call it as a haloalkane. It is alkane containing a halogen. So haloalkanes. The chemical properties of this particular carbon compound will be provided by the halogen group. That's why it is called as a functional group. Similarly, we can replace bromine with the fluorine also. Let us take one more example to check the name. Let us say in your question paper, you find a question like this. This formula is given to you and they have asked you to write the structural formula and name the compound, let us say for 2 mark. So this chemical formula they have given. How will you write the structural formula? Structural formula means you have to expand it and write it. So check how many carbon atoms are present. 1, 2, 3. And the halogen group, it is attached to the middle carbon. So we have to number the carbon atoms. So numbering could be done either from this end or this end, does not matter. In this case, this could be carbon 1, this could be carbon 2, this could be carbon 3. However we number it, either from this side or from this side, the number of this carbon will always be 2. So does not matter. Therefore, as you know, write down the carbon atoms. There are 3 carbon atoms. Let us say this is the first carbon, this is the second carbon, and this is the third carbon. You don't have to write the numbers here, just for your understanding. Then, because it is an alkane, we join them with single bonds only. And finally, we have first carbon has CH3. So there are 3 hydrogen atoms attached. So as you can see, there are 3 valencies free. In the last carbon also there are 3 valencies. So we can attach the hydrogen atoms. So hydrogen atoms are taken care of. The second carbon, it has got attached to 1 hydrogen atom and 1 chlorine atom. The chlorine atom can be written above or below, it does not make a difference to the answer. So now we have drawn the structural formula, the structure of this particular compound. This is the structural formula. And what is the name of this particular compound? As again, count the number of carbon atoms. 1, 2, 3. Any carbon compound containing 3 carbon atoms will have the nomenclature as prop, as you know. There are all single bonds, which means it is an alkane. So the name will end with a ane, propane. And there is also one halogen group attached here. And whenever halogen group is attached, it will start at the beginning of the name. The name will be chloropropane, and we have to check to which carbon atom is this chlorine attached. In this case, the chlorine is attached to the second carbon, and we have to indicate that in the name. When we say chloropropane, it means that chlorine is attached to the first carbon. But that is not the case in this structure. It is attached to the second carbon, so the name would be 2-chloropropane. So 2-chloropropane would be the name because chlorine is attached to the second carbon. This is the name of this particular structure. The steps are exactly the same. Count the number of carbon atoms, check what type of bonds are present, and check whether the functional group, what is the functional group attached, which functional group is present, attached to which carbon, what is the functional group and attached to which carbon. That's it. 3 steps we can write the chemical name of this compound, 2-chloropropane. If chlorine is not attached here, whereas it is attached to the first carbon, then in this case the name would be 1-chloropropane or simply chloropropane. So this could be the first carbon or this could be the first carbon. The next functional group is alcohol group. When alcohol group is attached, the name will be added to the end as a suffix at the end of the name. It will end with the all, alcohol. So OL will be added to the end of the name. So let us see how. And what is the formula for alcohol group? There is one valency free and there is a OH group present together. So whenever you see OH present together, it means that that particular carbon compound is a alcohol compound, and the properties of the compound will be contributed by the alcohol functional group. So let us write a few structures for alcohol compounds. This is given to you: CH3, CH2, CH2, OH. Write the structural formula and name the compound. Count the number of carbon atoms: 1, 2, 3. Draw them in a straight line. Join them using single bonds. And first carbon, let us say, is attached to 3 hydrogens. The second carbon is attached to 2 hydrogens because it can attach only to 2 hydrogen. So valencies of carbon are satisfied. And finally, the last carbon is attached to 2 hydrogen, CH2, 2 hydrogen, and there is a OH group. The OH group is attached with the single valency. So if this OH group was not there, there would be a hydrogen group. So the hydrogen atom is removed, and in its place this OH group will come and fulfill the valency. There are 3 carbon atoms, so the name will begin with prop. All single bonds are present, which means it is an alkane, propane, and there is an alcohol group, OH group, attached to the carbon. So whenever OH group is present, it will end with the all. So we have to remove this E and add a all. So the name of this compound would be propanol. So instead of E, we add a all. One carbon atom is removed, then what would be the name? So when one carbon atom is removed, then the name would be, there are only 2 carbon atoms. Whenever there are 2 carbon atoms, the name will begin with the eth, and all single bonds are present. So ethane, and there is an alcohol group present. So remove the E and replace with the all, ethanol. So ethanol is the chemical name, scientific name. What we call it as alcohol. Generally we call it as alcohol. Ethanol is the main constituent present in alcoholic drinks such as whiskey, rum, wine, also present in small amounts in beer. So all alcoholic drinks, they contain this particular carbon compound, ethanol. It has the molecular formula CH3 CH2 OH. This can also be represented as C2 because there are 2 carbon atoms, H5OH. The OH group here shows that the functional group present is OH, that is alcohol. Or it could also be written as C2H6O. 5 plus 1, 6. So in the question paper, you could find it mostly either in this form or most probably in this form. So whenever you have C2H6O, it is ethanol. If it is propanol containing 3 carbon, then the molecular formula would be C3H8O. This is the compressed form. So this is what you would find. Ethanol is C2H6O, propanol is C3H8O, butanol would be C4H10O, so on and so forth. So that is the functional group alcohol attached. Let us move on with the next functional group in today's discussion, that is the aldehyde group.